What I want to do tonight is to give you a basic introduction to the amazing power of stem cell nutrition. You don't have to write any exams, so none of you should feel like you're in school. This is not intended to fill your brain full of a lot of information. What I want to do is to give you, before you leave, a perspective of what stem cell nutrition is all about. If you gain that perspective, it could literally change your life. Because just the awareness and the understanding and the application of what we talk about tonight has the power indeed to change your life and the life of many people you know. So with that, let's get started. We talk about the amazing power of stem cell nutrition. This is a remarkable subject because it brings together two fields of scientific endeavor and personal endeavor. On one side, we speak of stem cells, which today in the scientific community is as hot as anything else and any other subject. And it also brings the subject of nutrition into focus. And nutrition, of course, is as ancient as the hills. So in a sense, we are kind of mixing and matching something that's very current, very up-to-date, very mainstream right now in the area of stem cells, and something that is as old as the hills. As long as human beings have existed, we've all depended on nutrition to sustain our lives. What is very new and exceptionally new, and perhaps very unknown to the rest of the world, is that these two fields actually find a point of merger. In other words, there is an area in which stem cells on the one hand and nutrition on the other hand actually come to an interface. And what I want to do tonight is to bring you to that interface. I want to show you how stem cells relate to nutrition and how nutrition relates to stem cells. And at that interface, you're going to discover something that the rest of the world needs to know and does not yet even think about. There is right now a stem cell revolution. That is so obvious because almost every time you open your newspaper, turn on your radio, look at your television, you're hearing something about stem cells. Why? Because it is at the forefront of science. So much so that today there are thousands of research laboratories actively engaged in a search. Everybody's trying to make the latest discovery at this frontier because at any of these areas on the frontier, they can make a breakthrough that could become so revolutionary as to change the lives of millions of people. We are engaged in a revolution. And in a revolution, there's fast change, fast development with major implications. It is a scientific revolution because it is based essentially in science. Science has now discovered, and notice my word, discovered. They didn't make this, they didn't create this, they didn't do this. They have discovered something very important about the human body and about life itself. That in our bodies exist some cells that have unique properties. We call them stem cells. And those properties are so revolutionary that they actually offer the opportunity to change the very entire way we practice medicine, the very way we actually engage our normal lifestyles, and in a sense, it can actually impact the entire world. But there's a political component to it. And when you introduce politics, of course, that brings it right onto the front page. The political component came about because initially, we learned a few years ago how to harness stem cells using human embryos. And that is to say, when the first egg and sperm fertilize and begin to multiply, after just a few divisions, they form something called a blastocyst or blastula. It's a very small conglomeration of cells, but it's the very early human embryo. And this very early human embryo is essentially made up of cells that still retain some of what we call pluripotency. That is to say, they still have the capacity to become later many different kinds of cells. And because of these so-called embryonic stem cells taking the lead And because we learned to culture them first and to start to manipulate them and to harness them and to understand some of the science of stem cells, initially, all of stem cell research was focused on embryonic stem cells. But that introduced a problem because some ethicists and many, many persons around the world, and some in very high places and so on, and great influence in religious circles and so on, have a problem with using embryos in this way and for this purpose. And so, of course, it became a political issue because what are we supposed to do? And about 10 years ago or so, there was a major political problem of what we do about embryonic stem cells, and should government support it? Should it be done only as private research? Should there be public funding? Some countries wanted, some countries didn't want, and there was a whole lot of political give and take. And at that time, the whole issue of stem cells seemed more wrapped up in the politics and the ethics than in the science. But today, all that has changed, and I'll tell you why in a minute. The second basic factor is the media got involved. So not only you have science and politics, now you add the media, because the media found out that these stem cells had the prospects of becoming cells of every type of tissue, and therefore it generated the possibility of what is called regenerative medicine. That is to say, if these stem cells could become any cell in the body, become any tissue in the body, perhaps we could use them to make spare parts for the body. That's essentially what we're talking about. So we thought of things in the body that had become degenerate, whether it be an organ, whether it be a nerve, whether it be a bone, a joint. We suddenly started thinking of using stem cells to regenerate these tissues. And the media got involved and blew this totally out of proportion. And now we were beginning to talk about taking people out of wheelchairs and people with spinal cord injuries who are paraplegic and quadriplegic and so on. And as we started doing this type of exaggeration, the public began to anticipate even more. So lots of people and lots of families who had chronic sufferers suffering from all kinds of illness began to get hope. And suddenly there was this great expectation that maybe stem cells will stop my father from deteriorating with Alzheimer's. And maybe my mother who's got diabetes will no longer need all this diabetic medication. Her blood sugar will stop going all over the place. And this person's got liver disease or, chronic renal failure and so on. All kinds of medical issues. The public began to anticipate that maybe stem cells would give us the solution. And then in this past year, we were very privileged to note that the latest Nobel Prize in Medicine, last year in 2012, was awarded to two scientists in the area of stem cells, as if to put a punctuation mark on it. There had been one done a few years ago when we started generating some specific mice and giving these mice specific properties. I got a Nobel Prize for that. But recently, in our time, and just very, very recently, two particular scientists. One scientist, Professor Gordon, had done many years ago, almost 50 years ago. He had found out a method of proving that every cell in the body retained its basic DNA, which means that in a sense, all the cells of the body are alike, but each cell has its own way of turning on certain parts of its DNA to make it do certain things, and a different cell turn on different parts of its DNA to do different things. And then, in 2006, a much younger scientist, Dr. Yamanaha, he actually found a way of taking any cell in the body and reprogramming it in such a way as to make it back into being a stem cell so that it could then become any other cell in the body. If you didn't understand that, what I'm saying is this. You could take a cell from your skin, convert it into a stem cell, and now train that stem cell to become any cell you want. So all of a sudden, for example, we didn't need embryos anymore. So today we are far gone from the whole embryonic debate and all that stuff. Anyway, the stem cell revolution is here. And what I wanted to do was perhaps introduce you to this very important concept at the outset. There are two major activities that you need to distinguish. Stem cell medicine is what I've been talking about up until now. That is to say, there is a whole thrust in the medical and scientific community to use stem cells in the practice of medicine. And as I say, thousands and thousands and maybe hundreds of thousands of researchers and clinicians and so on are actively engaged in this idea of trying to bring stem cell technology in the service of medicine, in the treatment of disease, in the curing of ailments and so on. That's stem cell medicine. What has not become popular yet, but which in a sense is far more important in another sense, is the whole issue of stem cell nutrition. This is a field totally different from stem cell medicine. Here in what I'm going to talk to you about tonight, my focus is on stem cell nutrition. And I want you to appreciate the difference, because it is the same difference that exists between food and medicine, between nutrition and medicine. Similarly, there's a distinction between stem cell nutrition and stem cell medicine. And the first observation must be that food came long before medicine. Food is far more widespread than medicine. Food is used by far more people than medicine. Food is a far bigger industry than medicine. Similarly, stem cell nutrition has the exact potential of invading and changing lives of millions of people as they begin to understand the value of nutrition and utilizing the benefit of stem cell nutrition, even in advance of all the research developments of stem cell medicine. We'll come back to that, but that's so important. I'll go back to that in a minute. Well, let's just be clear. Let me say something rather basic. Because somebody might be here tonight, somebody might be listening to this presentation, and does not even appreciate what stem cells are. So for those, let me just say this. There are two particular properties of stem cells that make them rather special and very important and in some ways unique. The first one is that stem cells have the capacity to proliferate indefinitely. That is to say, stem cells just keep multiplying, proliferating, making more of themselves through several or through many generations. Some people up to 30, 40 generations. And if you take one cell and you just double it and double it and double it and double it, and you double it 30 times, you're talking about billions of cells. So that's the capacity of the individual stem cell to generate millions and sometimes perhaps billions of cells. The second thing, which is probably just as important and in some ways more important, is that stem cells have a second property, which is the property to differentiate. And what that means is you could start with a given stem cell, and just by the way it is influenced, either by nature or by science, the influences on the stem cell can cause the stem cell to become cells of many different types. And that's an important quality and property which gives the stem cell this great power. Now, I want to talk about the three types of stem cells just so we can all be clear and use the same language. I mentioned earlier embryonic stem cells. These are the stem cells derived from these early embryos, which in a sense is still being done, still being used for research, but is really today the very minor part of stem cell activity. What is far more important now is we have come to understand the role and influence of adult stem cells. Now, adult stem cells is a misnomer. What do I mean? It is not stem cells necessarily for adults. Adults are really, the term is used as in contrast to embryos. So anything that is not an embryonic stem cell is an adult stem cell. So the adult stem cells are present in babies and in the fetus, even before the baby is born. They're really adult stem cells, even in the womb. They're not embryonic stem cells. And we now understand and appreciate that the real value of stem cells in an immediate application, as of today, and in widespread application, is actually the adult stem cells that provide us this tremendous opportunity. And I'll tell you why in a minute. The third type of stem cell is certainly something that you need to appreciate. And if you want to have anything to do with stem cells, you at least perhaps ought to get some basic understanding of this. Because this is really where it's at today. Today we take stem cells, as I said, because of the work of these Nobel Prize winners, and we are able to induce, that's the key word, we're able to cause mature cells, different types of cells. We're able to cause them by some particular manipulation of some important genes, typically only 4 or 5 genes, that's all you need, but they're specific genes and they're done in a specific way. You're able to convert ordinary cells back into being stem cells. In that way, they are induced And they are induced to become stem cells, which then have this capacity to become any other kind of cell. So they become pluripotent. That's what the technical term is. So we induce this pluripotent stem cell. And so these types of cells are the cells that everybody's using today almost routinely now in a lot of advanced research, and a lot of the applications and trials and clinical trials and so on are involved in using induced pluripotent stem cells. Tonight I'm going to speak more specifically about adult stem cells, because I'm going to speak about using stem cells even before the scientist gets involved. And that's the key, and it will be a big key. Now, let me introduce you to the main thing about stem cell nutrition. It derives from an accidental discovery. I say accidental because nobody really anticipated this and went out and, in a sense, because of their brilliance, discovered it. This was an accidental discovery because Christian Drapo and Dr. Gita S. Jensen from McGill University, as they were trying to understand why an ordinary, common, natural product was having such diverse effects and benefits for a wide variety of people over time, they began to ask what might be going on here. And as they read and as they studied and as they thought about it, it dawned upon them, listen to my words, it dawned upon them like a eureka moment that maybe, just maybe, this might have something to do with stem cells. And when you read my book, you're going to read all the details of how this came about. Because just with the idea, what if, could it be, perhaps, it led them to perform an experiment. An experiment simply to test a hypothesis, an idea. And the idea is simply summarized in what is called today the stem cell theory of renewal. And here's what it says. It simply says this: we now know unambiguously, unequivocally, that all people, all human beings, have within their bodies stem cells. That is without question. Everybody knows that. We have been able since then to prove that these stem cells derive from the bone marrow. In other words, for many years, when I was in medical school 30 years ago,